This video is about using z-scores to calculate percentages. You're going to need a z-score table such as this, so have one of these handy. The level of cholesterol in the blood is important because high cholesterol levels may increase the risk of heart disease. The distribution of blood cholesterol levels in a large population of people of the same age and sex is roughly normal, meaning a bell curve. For 14-year-old boys, the mean is 170 milligrams of cholesterol per deciliter of blood, and the standard deviation is 30 milligrams per deciliter. Levels above 240 may require medical attention. What percent of 14-year-old boys have more than 245 milligrams per deciliter of cholesterol? Alright, as soon as I see that they're asking me for a percent like this, and I'm given the standard deviation and the mean, I'm thinking, okay, I'm going to need z-scores to calculate the percentage. Now, they did not leave us enough space for me to do this the way I like to do it. Let me just skip ahead and just show you how I have number 3 set up, for example. So even if they don't give you a box like this or even a lot of space, if I were you, I would get another sheet of paper out and do the work on a separate sheet of paper and staple it. Just label it clearly. So that's what I would do right now. Now I'm doing this on a computer, so there's nothing to stop me from copying and pasting. But like I said, if I were you, rather than trying to squeeze this in this tiny amount of space here, I would go ahead and do it on a separate sheet of paper. So that's what I'm going to do. Go ahead and draw a normal curve in the first 2 boxes. Now in the first box we're going to use whatever units they give us. We're talking about cholesterol, and the units we're using are milligrams per deciliter. In the next box we're always dealing with z-score. So of course in the middle goes the mean. In milligrams per deciliter, the mean is 170. So go ahead and put down that 170. The mean z-score is always going to be 0. So we want to know what percent of 14-year-old boys have more than 245 milligrams per deciliter. Well, 245 is certainly higher than 170. So I'm going to put that over here to the right. Okay, so here's my 245. And I'm going to put a similar mark on the z-score graph as well. Okay, let's see, what percent of boys have more than 245? So I know I'm interested in the part of the graph that is to the right of this, so I'm going to go ahead and highlight it this way. Okay, now as soon as I do that, I'm thinking, wait a minute, is this the situation where I can read my percentages right off the z-score table, or is this the one where I have to subtract from 100? So I'm just going to mention now that this is the one where I have to subtract from 100. Anytime you are going to the right, okay, if you're shooting for the part of the data that is above a certain value, those values are not what you find on the z-score table. This little picture is giving us a hint. These numbers represent percentages to the left of whatever z-score we find. But it's always to the left. If you want the part that's to the right, you have to subtract from 100. Anyway, first we have to find what the z-score is. So let's turn this 245 into a z-score. Okay, so our z-score is always going to be the value minus the mean divided by the standard deviation. In this case, the value is 245, alright, minus the mean, which was 170, divided by the standard deviation, which I believe was 30. Okay. So if you just put that in your calculator, you get the z-score. Okay, that is 2.5 is my z-score. Now, I need to write a percentage statement next. So I want the percentage, oh, by the way, as soon as I get that 2.5, let's go ahead and put that in the picture. So that's the z-score version of this number. So I'm going to put 2.5 right there. Now, I want the percentage of z-scores that are above 2.5. So I write that this way. The percentage of z-scores that are greater than 2.5. And like I said, we're going to have to subtract from 100%, so I might as well get that started. So let's find what percent of the data is below 2.5, and that's what we have to subtract from 100. And that's what this is all about. So if I find 2.5 here on the left, okay, so here's 2.5 right here. So that means this is the percentage of data that's to the left of 2.5. Alright, so that is 99.38%. Okay, so I'm going to do 100 minus 99.38%. So that is 0.62%, less than 1%. It's a very small amount. And let's go ahead and record those percentages in our picture. So right here, this is the 0.62%. All right, that's the amount of the yellow area. So 0.62%. Less than 1% is above this line. And let's finally record our answer in words. So we will say 0.62% of 14-year-old boys have a cholesterol level above and it was 245 milligrams per deciliter. Alright, let's look at the next problem. Use the information above. What percent of 14-year-old boys have blood cholesterol below 175 milligrams per deciliter? Below 175. Alright, so let's get these two pictures going again. Alright, so once again, the first one is for our cholesterol, straight milligrams per deciliter. Our second graph is for the z-score version. So if we want to know what percent of 14-year-old boys have blood cholesterol below 175, well, let's get 175 in the picture. So here's 170, so 175 will be a bit to the right of this. Okay, so I'm just going to put my 175 right here. Okay, and similarly, I'm going to put it on the z-score graph. Now, it said below 175. Okay, so that means, you know, to the left of this. So here's 175. So we'll shade it in. As soon as I do the shading, I start asking myself, wait, is this the one where I can read the percentages right off my z-score chart? Or is this the one where I have to subtract from 100? And I know that when it's to the left, these are leftward numbers. I can tell, look at the little diagram here. It's reminding me that these numbers are the percentages to the left of any z-score. So I can read them right off the graph for this particular problem. Alright, but speaking of z-scores, I know I need to calculate the z-score. So let's find the z-score for 175. Alright, so I know my z-score is going to be the value that I've got, 175, minus the mean, which is 170, divided by the standard deviation, which I believe was 30. Okay, from the other problem I remember that. So just put this in your calculator and you'll have your z-score. Alright, I'm getting a z-score of 0.17. So I need to convert that into a percent. But first I am going to write my percentage statement. So I'm going to say, okay, we are looking for the percentage of z values that are less than, and I'm not going to say 175, I'm going to say 0.17 because we're talking about z-scores. And in fact, while I'm at it, I need to put this z-score in my picture. So 0.17 is right here. I do not need to subtract from 100 this time, so I'm just going to go straight to the chart. Now, when I read a z-score chart, I start with just the first two digits, 0.1. Okay, oh look, there's 0.1 right there, right off the bat. Now, this time I'm not just going to use the first column because there's more. It's 0.17. That 7 tells me to go all the way over here to this column, the one that has a 7 in it. So, I'm talking about 56.75%. So that's what this is, 0.75%. And that's it. Because it's to the left, I just read it right off of the chart, and that's all there is to it. So I'm going to go ahead and write this in words. So 56.75% of 14-year-old boys have cholesterol levels below 175 milligrams per deciliter. When you have a word problem like this, you have to write your answer as a sentence. Okay, let's go ahead and also include this percentage in our picture. Alright, so this shaded area, of course, is the 56.75%. Now, one of the reasons why I'm requiring you to write this down and include this in your picture mandatory, alright, and you will lose a point or two if you don't do it, is because I want you to have a moment to look at this and ask yourself, does it make sense? Does this look like it might be 56.75% of the data? Well, at least look at this. You know that the mean is right at 50% of the data, alright, when you have a normal curve like this. And so you can see that this is over 50%. So 56.75, almost 57%, that seems like it would be about right. Alright, once again we start off with our two pictures. Our top picture will be whatever it is we're actually dealing with, cholesterol, milligrams per deciliter. 170 is the mean. Our second picture will always be z-score, and z-score, the mean is always 0 when you're converting to z-score. So what are we supposed to find? What percent of 14-year-old boys have cholesterol between 160 and 235? Interesting. So 160 will be over here to the left somewhere. Okay, so this will be my 160. And 235 will be over here somewhere. Okay, 235. So between 160 and 235. Let's put some similar markings on the z-score graph. But when they say between, they mean it. So between means like this. Alright, so shade in between those two numbers. And same thing down. Now, this time we have two different values. We're going to need two different z-scores to represent them. So that's what we're going to do. Let's start with the 160. Alright, so that z-score is going to be I'll do the 160 minus the mean divided by the standard deviation. Okay, I feel like I should split this up. Put a line through here or something. Okay, so I'll calculate this in the calculator. Alright, so that is negative 0.33. Alright, similarly, we have another z-score for the 235. So that's going to be 235 minus 170 over 30. Alright, put that in your calculator. So I'm getting 2.17. So make sure you round properly. It really was 2.1666 repeating. But if I'm going to round to 2 decimal places, that would round up to 2.17. So these are my two z-scores. So now it's time to write that percentage statement. This is mandatory. So if I want the percentage of z-scores between two numbers, here's how I do it. I start with the smaller one, and I'll say negative 0.33 is less than the z-score, which is less than 2.17. Alright, so here's how I show the percentage of z-scores that are between two values. Alright, so when I'm doing between two values like this, what I do is I find the percents on my z-score table and I subtract them. It'll always be the bigger one minus the smaller one. But before I even do that, I'm going to record these z-scores on my graph. So this one over here on the left is negative 0.33. This one on here on the over here on the right is 2.17. Okay, anyway, so let's find these percentages. So negative 0.3, start with that. Okay, so negative, not 0.3, but negative 0.3 is right here. Alright, now it's negative 0.33. So this is the 0 column, 1, 2, 3. So this is that. That's 37.07%. Actually, I should have done the bigger one first, so let me come back to that, because I need to do the big one minus the small one. So let's find 2.1. We'll worry about the 7 later. So 2.1. Okay, I'll be seeing you soon, buddy. Alright, 2.1 is right here. And then remember it was 2.17. So this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this one is 98.50 or 98.5%. And now we need to subtract that smaller one, which was negative 0.33, so it's 37.07. Okay, so you just do that subtraction and that's your answer. So I'm getting 61.43%. Alright, so that's more than half the data. So let's go ahead and record that in our pictures. So 61.43% is the amount of data that's in between these two numbers. Same thing here, 61.43%. 61.43%. And finally, go ahead and put your answer into words. So there you go, 61.43% of 14-year-old boys have cholesterol levels between 160 and 235 milligrams per deciliter. Alright, that's going to do it for this video. It's getting a little bit long. The next video is really the same type of problem all over again. So I very much encourage you to stop this madness and try to do problem number 3 by yourself.